Good evening, everybody. Welcome to the February Symfony UK Meetup. We're very, very happy to have you here today with us. In fact, let me advance that slide because the stream has started now. We're so happy to have you all with us. We are trying out streaming on YouTube for the first time ever. I've already had a question, should the chat be working? Yes, the chat should be working. We were hoping that it would be, but something seems to have gone wrong. We're gonna, I don't know, hopefully that'll start working. Maybe Google will fix that, I don't know. But we're gonna try and get around that for questions today. Join me in my half redecorated room. Eagle-eyed amongst you would have noticed that it's changed from blue to yellow. We were actually decided to strip all the paint and the wallpaper off of this room, and there was like a 4-inch radius in that corner there of the wallpaper. And as soon as I stripped off the wallpaper, I realised it was hiding some massive cracks in the corner. So this is why this room is kind of a bit messy and half decorated at the moment. So as I say, we've got a fantastic lineup for you today. First up, we're going to have Jim talking about Tailwind CSS, and then afterwards we're going to have Kieran with test-driven architecture. But let's start off first of all. We have got Level 5 sponsoring one of the prizes tonight. Thank you so much to Level 5, who are going to be giving out a prize, a book prize that we have, which I forget what it is. Jakob did recommend a book to me earlier, and I will get back to you at halftime with which one it is. Thank you to Lendable as well, who are giving us the video infrastructure for tonight. Basically pay for me to have an account on Zoom that lets us be able to stream direct to YouTube. And thank you to JetBrains, because we always have JetBrains licenses to give away. Now, the idea of tonight was that we were going to use the YouTube chat for questions, but it seems that that's not working at the moment. So we have two options, and we will monitor both of these. First of all, if there are any questions in the talks, please do get them to us early. I think there's about 15 or 20-second delay between us talking and it going through to the YouTube stream. So please, please, please try and get questions in as early as you can. But you can either tweet them to us at Symfony UK, or you can ask questions on the Meetup page as well directly. We'll monitor both of those. So if you RSVP through Meetup, then get your questions in there. So let's get questions in as early as you can. That would be great. Thank you very much. We have a new raffle system tonight as well. I was going to put the link in the chat. I will tweet it as well. Symfony Meetup.org.uk. If you go to symfonymeetup.org.uk, I will tweet this out as well. We basically have a brand new raffle system which we put together. And again, if you can get your entries in early, that would be fantastic. And we will go through these and we'll get the raffle done at halftime. So like I said, we've got a book to win. We've got some JetBrains prizes to win as well. And hopefully, because it's the first live test of this system, it's going to go well. If it doesn't go well, then we'll have a good laugh about it. And somebody did ask me as well if I was going to make the source for this raffle available publicly, and I will make that repo available later on tonight. So let's, if I stop sharing, I will also stop talking. So tonight's first speaker is Jim McLean, who is somebody that I used to work with at MyBuilder. Let me stop sharing. So Jim is somebody that I used to work with at MyBuilder. He was a graphic designer for years and years and years. Moved into development, found out that he really loved doing development, and then became more and more kind of focused on sort of from JavaScript, CSS to JavaScript to Symfony. and when we were working together, he did some presentations at work, and he was always very engaging, really, really fun to work with. He did like a 45-minute presentation on the roundabouts in Milton Keynes or something like that. But by the end of it, we were just going, how do I see more of this? So with that, I am going to hand over. Let me do this. Right, okay. So I'm going to hand over to Jim. Jim, just let me know if you're able to share your screen, because Zoom is being a bit weird for me at the moment. You might need to, Jim.
I'm sharing now. Can everyone see stuff? Yeah. Good.
I have no sound. This is going really well as far as I'm concerned.
Oh, good. Can everyone hear me? All right. Give me a thumbs up if you can hear me. That sounds good. So yeah, I'll just talk for a bit whilst Neil plays with his sounds. So yeah, I met Neil at My Builder, and that was where I was introduced into using Symfony. Before then, it was sort of mostly CSS as sort of my main specialism, with a bit of JavaScript. So yeah, today I'm going to talk about how to organize your CSS to stop massive pain, and also to talk a bit about the latest and greatest in this CSS world, which is Tailwind, which is one of those things that, although it's come about very recently, it's really popular, and the people that use it love it. So it's well worth a look. But instead of jumping straight to Tailwind, I want to sort of take you on a little bit of a journey as to sort of how we ended up with Tailwind out there in the world, and give you a sort of a foundation in what you would do if Tailwind wasn't an option, which up until recently it wasn't. So what does a CSS architecture solve? Well, it stops you having bad CSS. And what I mean by bad CSS is CSS that you just can't touch, basically, because you don't understand it when you read it. You don't know what it's really affecting, or you can't be confident what it's going to affect, which crucially means you can't delete it. And being able to delete CSS is really where, when you know you're doing it right, when you feel you can delete some CSS with confidence. And that should be a part of the maintenance of a big project. And also, it's hard to add to, for a very obvious reason that's I'm going to explain in a second. So this is a contrived example, but this is how I think it goes wrong for a lot of projects. So you're tasked with developing this rather simple bit of UI, which is a simple card with a title, some text, and a link in. And you get given all the specs, and you think, this is easy, this is fine. It's basically a div with 3 elements in. Give the div a class, and you write a load of CSS, and it looks perfect. And you do this quite quickly, and it's fine. And then the next week, the same designer comes along and says, yeah, so we need that same card, but on the product page, it's not going to have that title. It's going to have 2 paragraphs of text in instead. So you think, okay, I'll just copy the card component with the 3 elements and replace the title element with another paragraph. And it doesn't look quite right. It looks like this one up here on the top. So you give it a bit more CSS. You say, when this card is on the product page, you're going to do something different to it. So now it looks perfect again, and all's well. And again, this is pretty quick to do, and everyone's happy. Now, a little while later, the same designer goes to you or someone else perhaps, and they say, yeah, we want the same card that we've been using on the product page, but when we're using it on the description, we want the top paragraph to be bold. And so you remove the link for a start, and then it looks all wrong still, like this one here. You've got this strange margin at the bottom, which shouldn't be there. And you know, there's no quick way to make this bold, except for maybe using the strong tag, but maybe you don't know about that. So you qualify it again. You say, well, when the card has a description in it, we're going to remove the margins from the paragraph, and then we're going to have this special intro paragraph text, which is going to be making it bold and giving it that margin again. And now, after all these simple changes, you have started a war, a specificity war. And over years, this can lead to some really terrible behavior, like eventually using the important tag, or putting inline styles, or even worse, using JavaScript to write your CSS instead. So how do you stop this from happening? Now, the sort of established architecture is called inverted triangle CSS. And it's called that because of this sort of shape that it makes, where you arrange your CSS into these layers, where each layer gets more and more explicit, and the specificity may go up towards the end, although it doesn't have to. I think ideally you want to keep your specificity at a level 1 all the way throughout. And this triangle, this sort of top to bottom, is an exact representation of your single CSS sheet, because after specificity, the next rule is which rule was declared last is going to actually style the thing. So what it promises is to define the dependency flow for a start, and it stops you from depending on the details. And by details, I mean the HTML elements, or it discourages that. And as another bonus, if you've done it really well, everything in each layer, in theory, can be substituted for one other thing inside that layer. So it allows you to make changes quickly. Now, the idea, or the name, was coined in 2015. There's a link to the article that explains a bit more in depth. But I consider this a sort of emergent solution from the technology. Just here in the sort of center of the screen is an example of the first release of Bootstrap. And you can see that the order of the imports is sort of a rudimentary version of the inverted triangle. And by their first sort of proper release, version 2, which was the next year in 2012, their organization matches the inverted triangle almost exactly, except they've added a few more and the names aren't quite the same. But the general principle is there. So it's kind of the way to do it, as far as I'm concerned. This is sort of roughly how the dependencies work in an inverted triangle, where everything from tools below will only depend on the tools and settings. The other layers do not depend on each other. And if they need to, then something has to be abstracted and lifted up to the tools or settings layer. And it never goes the other way. Otherwise, you can't swap things around. This is what your settings layer looks like. You will be familiar with this if you ever used Bootstrap or any sort of framework where you've got this settings file and you can kind of configure it. This is where your design decisions live. So when you've decided what colors you're using, or your font sizes, or even you've decided on space and time, it gives me a little chuckle whenever I see the fact that I've included space and time in my settings. So hopefully this one makes most sense. This is your variables, basically, more like constants, really. The next level down is a combination of handy utility functions to perhaps write some future CSS easily, or in this case, what my favorite section of it is I always have a mixins file which allows me to interface with my settings so that I don't depend on my settings directly. So on the left, I've got a map of values, and we use this mixin to interact with the map instead of getting things from the map directly, which will give us a lot more options in the future and means we can use it in a more programmatic way, which we'll come back to later. The next layer is the generic layer, which is basically where you have a CSS reset. And your sort of things that are just obvious to have, like the border box thing, is your sort of, if you had nothing else, you'd probably have this anyway. A reset comes in 3 flavors, which is your aggressive flavor. Aggressive flavor, I like that. Which basically just kills everything. If you have reset.css, then it's like somebody's taken every single style the browser has given you and just completely taken it out. So everything starts with padding 0 and margin 0, which Tailwind does this, which we'll introduce later. And then you've got your sort of rational flavor, which basically removes the inconsistencies between the browsers to stop weird surprises. If you haven't tested every device, you sort of puts it to a reasonable baseline, and basically just kind of kicks Internet Explorer with a stick and sort of tries to get it in line, although it's not really a problem. And my personal favorite, and is what I would use if I started a project today, which is a minimal one, where modern browsers, they really kind of behave, and if you believe that the rules that they set out are kind of sensible, then you'd only have a reset that's going to have only the most handy or most ubiquitous rules, like the border box. Next is where you actually start writing some real CSS, is where you're addressing the actual HTML elements, and should be the last time you address an element in the CSS. After you pass this point, you should really not be addressing the individual elements at all. Otherwise, you saw what happened. So here we've got like our buttons and forms, and our typography would probably address all the headings here as well. The next one is probably the most difficult one to understand, but if I had the power, I would rename this layer containers. So this has things like your grid system in it, where in Bootstrap, for example, this is where approximately at this sort of level, this is where the grid system is made. And this project from my builder, this is where we've got our sort of rudimentary layout system, which is very simple because it doesn't require a full grid system. And it's also got this sort of list of cards where once you put 2 cards together, they sort of, the corners sort of square off and stuff like that. Crucially, these have no paddings applied to them except for the grid, so I tell a lie. But yeah, this one's probably the most difficult to understand. It's not exactly intuitive. Next is probably the most easy to understand, components. And this is what people in my contrived example, this is where we jump to without doing any of the groundwork. So this is where most of the new CSS that's written after you've done your setup phase would happen. So it's for more sort of complicated and fancy things, basically. So like the navigation's a classic example. Is probably one of the most difficult things to manage in your CSS. Is probably going to be a component or perhaps two. Or this nice accordion, which has got all sorts of icons and areas for things to live. And this metro line, which has multiple states, you know, like at the top of a form with the numbers. So there's a lot going on here, but it's all sort of encapsulated in this component because it's likely to change together. And then you'd have your utilities. Now, this is a sort of foreshadowing of the Tailwind section, but this is what you would expect to have found in a utilities layer up until a couple of years ago. There's just absolutely handy utility classes just to do something that you always do, but you really didn't want to write a full component for, just to kind of move some text around or move a box around. So how do we get this into our Symfony project? So assuming you're using Webpack Encore, and assuming you already have a load of old CSS that you're not about to throw away because you don't have infinite time, what I've done here is I've pointed Webpack at the old CSS and I've made a new folder for each layer. And I've numbered them so that they sit in the correct order in the folder structure, which just makes me happy. I tried it without, and I'm always sort of looking for the folder I'm looking for, but this way sort of it always makes sense to me when I've got the numbers there. And so now I've got Webpack to give me two style sheets, and they're both using different CSS preprocessors, which is fine. Webpack's taking care of all of that for us. So it was actually super simple just to implement this new thing side by side. And then when you're just starting out, you might do some setup, define some of your elements. There's the examples I've written there in a component. But as the project grows, you can see some of the areas don't grow at all, like the reset. You're going to have multiple resets going on, and the settings level is really unlikely to grow further than those 3 files. And our objects has only ended up with 3 files, and it's again unlikely to grow past that. The components section has got lots of things in it, which is expected, and that's where most of the work is done. And we've also got a few more utilities, which I'll get into later. I always find it handy to add these sort of comments, and I take them from that article that's linked, and I have a link to the article and I label it so that if anyone else comes, they kind of understand that there's a sort of a reason for this list, and if they don't understand it, then hopefully they'll talk to me or at least read the article or something. But what I don't want people to do is start randomly putting anything in there. But what I do tell people is that if you're not sure, just make a component and we can refactor it later. So that's the safest option. If there's an established system, just make a component and then it's all sort of encapsulated there at the very least. So let's do that. So let's say we want to take that card that someone erroneously addressed the HTML elements in, and we're going to stop the mess from happening ahead of time. So the very first thing we're going to do is put it in the components level and name it something more specific. This is already an improvement. By simply naming it article card and keeping it in its own thing, it will stop people using it in other contexts, or at least question it. It kind of tells people what it is. This card only actually works when it's an article card with the titles and stuff, and to change it we really need to make something else perhaps. So this is going to help. Just doing this alone is going to help. The next step would be to stop depending on those elements properly. So here we're using the BEM syntax, which is my personal favorite because it allows you to keep your specificity at 1, rather than what we could have here is like card and then dot title, which would bump your specificity to 2, which is just ridiculous. So we've used BEM, and this will compile to 1 class for each sort of block here. And then we can attach those classes to the HTML. And the next thing we want to do is get rid of what I'd call magic numbers. So I think it's a maths term, but a magic number is like, you're not sure why it works, but it just, that's the number that gives you the right answer. And that's what we've done with our paddings and font sizes and all sorts. There's no sort of reason for them except that, well, they looked correct, or that maybe they were in the spec. But by replacing the magic numbers with variables, it gives them validity, and it makes them proper, right? If you have magic numbers all over the place, there's no end to the different values that you can have. Also, by doing this, it sort of means that hopefully other people will stop using them as well. So the two sort of benefits to sort of using variables, or a really modern name for them is design tokens. Again, remember I said it in the settings file is where you keep your design decisions. So back when I was a print designer, I learned that having fewer options gives a more visually pleasing result, often, almost always. So by reducing those options, it gives your design or your layout a sense of cohesion and purposefulness. So for example, I'd always set up a baseline grid, and there was a set number of positions that things could exist on. And it sort of makes things feel correct. And the same is true if you've got like font sizes all over the place, and you've got different pixel values of different gaps between things. It sort of is visually messy, and it's hard for your eye to sort of parse it and understand it. The other more sort of programmery benefit is that if you ever decided to migrate those values to something else and more sort of more modern or more useful or just better, then you're free to do that. So for example, here all these font sizes have been replaced with a more fancy rem declaration, which is probably more accessible and more flexible down the line. And that was a really quick thing to do, and I did that with confidence that it wasn't going to mess up anything or change anything. So this is where we've ended up with we've got a little twig component here, and it accompanies, the file name matches up with our component, and we've got our BEM classes, and this is good. This, you know, if you did this slowly and refactored your UI in this way, you would stop the specificity wars from happening. Great, but let's see what happens if we make more utilities. So remember that utilities layer only started off with a few really handy things like floats and text layouts. But let's add some more for paddings, margins, font sizes like the heading classes, and a couple for display. You know, for making something like display block or display flex, for example. So how do you make these utilities? So if you're using less or SAS, the method is mostly the same. You don't really have a lot of options for data structures in these languages. You've got a single variable and you've got a map, but the map can be nested with another map, and that's really all we need to do this. So what we've done here is we've defined our variables for space, and then we've immediately repeated them in this map, which is a little frustrating. However, the likelihood of these changing is quite low, and if they do change, then it's not really that difficult, because we are going to have like a finite amount of these. These are human relatable values, they're assigned decisions, so hopefully we shouldn't have too many of them. But having them as straight variables and as a map does mean that we can really easily include them directly, but also loop the map. So here we've just made a loop, and inside the loop it's making margins classes and some paddings classes for each value it's found in the map. That's it really. It's super simple, and if you did this for your margins, paddings, font sizes and display, then we can look at our article card again and replace these classes actually with our utilities. Here I've used strong instead of a sort of font size utility, but look at the amount of CSS we've managed to delete by just having those handful of utilities. Now, again, this is quite a contrived example, but hopefully give you a taste of what happens if you rely more on utilities. What more can you do? And the reason why I think doing, and I'll come back to that later. So once we've replaced all of the internals with these utility classes, the parent class isn't really an article card anymore. It's just a card. And if we don't have the padding involved in this card, then it becomes less of a component really. It's too simple to be a component. It doesn't really have any moving parts. It doesn't have multiple things that are going to change together. It's really a box that you can put stuff in, kind of like a grid or a list or something. So here I've moved it into a new file in the objects layer called containers, which might have a few other things like, card with a bigger shadow, or, a gray area or something like that. And this is how we can solve those other two problems in the contrived example, where we're not actually writing any new CSS to achieve it. We're just changing some of the classes. So to give it 2 paragraphs and them to be a little bigger, we can change our font size class and remove the strong tag and just kind of fix the margins in place. And then similar story with the next one. So we've had 0 new CSS to write, and we've solved both of these problems. And the reason why I think this works is that these sort of things, these really basic things like sizes and gaps between things, are more tightly coupled to the content than they are anything else. So in this file, these classes are more tightly coupled to this text1 variable than they are anything else. And that's why I think they live here. Our card class is fine. You know, we can define those, a few of them, and use them in lots of places. But when the content changes, normally the font size and the margins and stuff will change with it. So some of you might be thinking, well, hang on, you can't actually do this. I included the 2 style sheets. I got Webpack Encore to compile 2 of them, and I just included them. That wouldn't work because if you had both of them on the page, you'd be fighting with the old one, and your new CSS would be bad. You would have to sort of quash the old CSS before it would even take effect. And removing the old CSS isn't really a practical option. If you think, you might have to rewrite the navigation styling. But then what about the other pages that you haven't migrated yet, or the other areas? So then you might end up with 2 versions of the navigation. One that's compatible with the old CSS, one with the new. I think you can easily understand why that would lead to terrible things happening. And the only real option in that case is you'd have to rewrite everything before you could write anything. It would take years, and then you could just start over again and nothing would ever happen. So this is sort of my idea, and I tested this with some real CSS. I couldn't find some really bad CSS, but I used some CSS I know well and work with at my builder. But I included all of it, which is 10, 12 years of writing CSS, although it's actually not that bad at all. But there's still 12 years of CSS there. It has Bootstrap 2 as a base, and that's still sort of present in the code base, so it's all there. And what I did is I added an ID to the HTML tag, which I can include in each template with this has new CSS variable. So I could overwrite that. And then any page that I want to include my new CSS, it will print that ID and also include our new CSS tag style sheet. And then in SAS, I basically took all of the imports in the triangle structure and just put them inside a ID tag. So I've like nested them inside it. So this is effectively prefixed the entire new CSS. Now, so that should work for most cases, because any number of classes will be overwritten by a single ID. So once the purple number or the top number has any number greater than 0, it doesn't matter how big the numbers below it are. So we've trumped everything, and it means that we don't have to write bad CSS. We don't have to use the important tag, which will have unintended consequences, like overwriting inline styles. We don't have to try and beat the old CSS. And this sets a good precedent and keeps your code clean. Otherwise, there's just no point in doing it. You might as well slowly just refactor the old CSS. Now, some of you might think, well, I've got multiple IDs. You know, I might have like a main and then a sidebar and then a sign up form. There might be 3 IDs deep in there. That's no problem, because you can just repeat the same ID using selector chaining and it will trump anything. And you can do this. You can do this up to 256 times. So if that doesn't help you, and if that doesn't solve your problem, and you do need more than 256 IDs to override your old CSS, then now there's never been a better time to get into a different career. The My Builder Trade Academy has everything you need to start up your new career in a practical trade. It's a really rewarding place to work, and you can leave all your IDs behind. So after sort of waxing lyrical about how good the utilities are, I'm not the only one to think that, well, what if you went really far with them? What if you just went all in on IDs? I mean, on utility classes. So we've got some examples here of sort of pre-Tailwind examples that didn't quite take off in the same way. We have the rather good tachyons, which is quite good for small projects, and the rather terrible atomic CSS. I say terrible because the classes that it ends up writing are madness. They're pure madness. I mean, you'd need to be referencing and looking these things up to actually understand what's going on, or inspecting the element once it's rendered to the page. And it just feels like the same thing but with extra steps, and it abbreviates everything. I mean, who knows what DCLZ stands for? I looked it up before the talk and I've forgotten, but you'd have to look it up. Decimal leading zeros. There we go. But this is incomprehensible, and is no better than where we were. So this was an interesting idea to generate a load of CSS with JavaScript, but it never went anywhere. So the thing that, although tachyons was quite good at the time, although some people hated it because it had unsemantic classes, it wasn't responsive, or it was only responsive in a sort of a limited fashion, in that if your initial values were responsive values, then it would be, but you can have really responsive, where things are relatively different on different viewports. So I mentioned before that you can make utilities by looping a map. Now, if you looped one map and then another map inside that loop, that's all you need to make a set of responsive utilities. So what we've done here is we've looped our breakpoints map, and then in each breakpoint, we've wrapped it in a breakpoint using our mixin, and then looped our space map, which is going to output classes like this, where they're prefixed with the breakpoint. And so now we can apply different rules at different breakpoints. So we can say, oh, when it's on mobile, we're going to have only a tiny bit of padding, and then as the screen gets bigger, we can have much bigger CSS, much bigger padding that's not just the same but scaled up, if that makes sense. So this isn't a new method, and in fact this is how Bootstrap makes the grid. Is it will loop a map of breakpoints and then sort of loop its number of grid columns. So this is not a new thing, but what Tailwind's done is it's sort of taken that responsive utility idea and just completely gone to town with it. And the difference between Tailwind and Atomic CSS is the class names are intuitive. So you could jump straight to Tailwind, and instead of doing all the other things I've said up until this point, you could just jump straight onto Tailwind. And if you did that, then you wouldn't have to bother with the architecture, because everything's already, the specificity's already controlled, because a utility can't have a specificity of higher than 1, really. Although once they get stateful or responsive, the specificity goes up a tiny bit, but not really. And the documentation for the Tailwind is brilliant. You know, the website is really good, and it's really quick to navigate. It's got a really great search function. So you could, once set up, you can sit down with that and really get things done quickly, and just kind of bash stuff out and really sidestep those architecture issues completely. And like I said, people who try Tailwind, they really enjoy it. It's very highly, like, have like a high NPS score if there was one. So I mentioned that it's taken the idea of responsive utilities really far, but it's also got these other prefixes as well, which makes it very powerful. So for example, with a hover prefix, instead of like a medium or large, you can change a background color of something. So all of your stateful stuff can just be listed out in your HTML effectively. Now, if you want to get started with Tailwind in your Symfony project, I'm not going to say that it's easy. It did take me a couple of hours, even starting a new one, because I installed the latest version and it's not compatible with Webpack Encore currently. I discovered this is a pretty common issue. So make sure you install the post CSS 7 compatible version until instructed otherwise. So at this point, you're going to get, if you're sort of normally a PHP Symfony developer, you're going to be kind of horrified by the amount of dependencies that are about to come in just to write some CSS. But that's, you know, that's just how it goes. So we're going to need post CSS, a way to process it with auto prefixer as well, and the actual Tailwind library. And another sort of way post CSS plugin that's going to sort of transform things properly at the end. For the latest stuff, go to the Tailwind site or follow this link here. So you need 3 files, although the config is optional. It's really not optional. You should really have it. You need a Tailwind config, a post CSS config, and then your CSS file. You can see I'm including the extra plugins in the post CSS config here. We're going to come to the Tailwind config. The Tailwind CSS file basically is just including 3 parts of the Tailwind library. The base is that CSS reset we talked about earlier on, which should be in your generic layer, which is completely nullifies everything. So if you have an existing project and you include this, it might produce some strange results. So you might want to skip that or experiment with not including it. The components layer is basically somewhat advanced usage of Tailwind, where you kind of can glue a load of utilities together and redefine them as a CSS class. I'm not sure how I feel about this, as it seems like doing the same thing but with extra steps, but this is where their output, again, thinking about the traditional triangle structure, your components have to be before utilities, otherwise utilities don't work. And really, if you want to use Tailwind, you have to use Purge CSS because it outputs thousands of classes. So using Purge CSS, it brings in another, like it does, Tailwind does have Purge CSS built into it. You can just add into the config file like areas to purge, but it didn't work for me in my Symfony project. Maybe I wasn't doing it right. So the sort of legacy route is to include Purge CSS manually in our Webpack Encore, in our Webpack config file, which means bringing in a load more dependencies just to get it to start, really. Now, I would recommend having these three things in your project, but maybe the second two commented out until you need them later. You'll definitely want to be looking at your twig files. So what this is doing is it's looking at the CSS file that's output, looking at the files you point it to, and only keeping CSS classes that are actually used. Everything else it will purge. And it takes ages to do this. It uses regex and it scales exponentially with your project. This project that you see, this 30 seconds, sort of 8 seconds here, is like a hello world type program. It's really small and it takes forever. So if you've got a really big project, like this is gonna, just buy a big server or something. But yeah, you want to be making sure you're purging your twig templates, your JavaScript for any stateful classes. Maybe you've got an is hidden or something like that. And I would recommend looking at your form types in your project, as the difference between some form types might just be a single class. So if like me, that doesn't really sound too great, and you'd want to try and have a bit less of everything, what you can do is only include parts of Tailwind that you actually need. How am I doing for time? We're running out of time. Running on a bit. It's fine. I'm near the end. So this is my alternative approach to including everything and then immediately scrubbing it out again, is carefully going through your config file and only including the utilities you're actually using in your project. So for example, here what we've done is replaced our utilities for space, font size and colors, defined only those in our config. So it won't output all thousands of classes, it will only output these, and only outputting the 12 spacing classes instead of the sort of 20 or so that it comes with. And even without purging, it was quite small in the scheme of things. So that might be an option for you. Yeah, that is actually the end. So did we manage to pick up any questions through YouTube or otherwise?
We do have one question, which is not necessarily a question, might be a statement, but did you have Node, Oliver asks, if you had Node env equals production when trying to purge CSS with Anchor? That's what enables purge with Tailwind, and Anchor doesn't do that by default.
I did try assigning it manually into the script, into the packages script. It still didn't work, but that might be the solution.
Gonna have a look at Twitter. No, not questions on Twitter. No questions on Meetup page. Joe says, hi, Jim.
Oh, cool. Hi, Joe. Yeah, I would recommend, like if I had more time to play around with it, I would go down the route and trying to get the built-in version of Purge CSS to work. And I think that's really the only way to go, because otherwise there's just too many dependencies. It's just madness. But my personal recommendation is to use Tailwind in combination with another sort of well-structured set of CSS, because it doesn't really work that well for sort of more fancy and complicated things. It's debatable, but that's my opinion.
Right. I don't think we have more questions, so thank you very much for your talk. It's very good. Neil, have you managed to join?
I have managed to sort out my sound issues, but I have myself coming through headphones as well as my actual voice as well. That's frustrating. I'm going to turn my video back on. Everybody can see me, I hope. Jim, that was fantastic. Thank you very, very much for your talk there. Again, really engaging, really interesting. Didn't mention the roundabouts in Milton Keynes this time, which I was kind of disappointed with. Okay, so I'm going to share my screen now. And we're going to run the, let's make sure my AWS keys don't come up there yet. So we're going to run the raffle script now. I saw a few people had signed up to it. In fact, if we just give it, if you go to symfonymeetup.org.uk and sign up now, the link is in the YouTube chat. I'm going to give you about another 20 or 30 seconds to go in there and do it. I think we've got about 30 people have entered the raffle so far. So if you want a chance of winning, you do have quite a high chance at the moment, because not many people have entered the raffle. So in terms of what the raffle, whilst we'll talk about what the raffle prizes are whilst we wait for people to do that. So Jakob, you were talking about the book Building Evolutionary Architectures earlier. I think we'll give that one away today.
Very nice book.
Which looks like a really useful book, actually. And of course, we've got 2 JetBrains licenses to give away. And the book Building Evolutionary Architectures, that is being sponsored by level5.co.uk. So I believe they're hiring as well. So if you go to level5.co.uk, there is a careers page, and they've got a list of about 20 or 30 different positions they're hiring for. So get in touch with them. Or of course, if you want to work with me at Lendable, come and get in touch with me. I'm moving house, so I need the referral bonuses. So do absolutely ping me directly, not anybody else, if you would like a job. Okay, so let's run the raffle script now. I think that's enough time. I am sharing, aren't I? It'll be. Now, this is the first time that we've run it from DynamoDB. So let's hope it works. So let's go for the JetBrains license first, or the first of 2 JetBrains licenses. Let's see what happens. So we've got 30 entries there. We're shuffling. You've seen this before. So Adam Reddy, congratulations. I will ping you via email with a JetBrains license tomorrow. And please do, if you do win the JetBrains licenses, please do use them. You can use it to extend the current license, but JetBrains keeps sending us threatening emails saying that they're going to stop sending us licenses because nobody is redeeming them. So please absolutely do redeem the license. So we've got the second JetBrains license to give away today. Let's run this one. So again, 30 entries. The second one is Martin. Martin, again, I will email you with your license code tomorrow. And then finally, so this was the book. So the winner of the book is going to be Joe Carter. Right, it was Joe who is really, really lucky on our raffles. So congratulations, Joe. So right, if I stop sharing now, so our second talk tonight obviously is Kieran McNulty. Now Kieran is the maintainer of PHP Spec, which is the Spec BDD tooling, so ubiquitous, used all throughout the PHP community. Kieran is obviously a big name in testing in the PHP world. He's been a member of the Symfony community in London for at least as far back as I can remember being a part of the community myself. I mean, he's worked for Invika, he's done all the blog posts and the training with Invika, and runs his own consultancy company now. And we're extremely lucky to bring him back to the stage virtually, of course, for the Symfony UK Meetup. I don't think there's anything else I need to say. I mean, Kieran, please take the stage. It is all yours. Big round of applause, please, from everybody for Kieran tonight.
Thanks a lot, Neil. Hi, everyone. Let me see how to share my screen. Does that look like it's working?
Yes.
Cool. Thanks a lot. So first off, I'd like to apologize if you hear any weird noises in the background. My 3-year-old has just woken up, but I can hear that it's being dealt with. So today, we're going to talk about test-driven development, basically. I've been doing TDD for a while. I started working with a team who were writing unit tests, and then slowly got exposed to this idea that maybe if you write the tests first, magic stuff happens. And you see people talking about this a lot, at different conferences and meetups like this. By the way, the chat is working, and I'm going to keep a little eye on it. So do ask things as we go. We might answer things at the end, but if there's something that's unclear, just ask in the chat. And about 20 seconds later, I'll spot it. So just to recap what TDD is, it's the idea that you're going to start everything you do by writing a test, and which is counterintuitive. But when you write that test, it's going to fail. You're then going to write some code that makes the test pass, and then you're going to refactor it. You're going to improve things. And for me, the big benefit of TDD is that you start by thinking about tests, writing a test. You're thinking about design. So you're thinking about, what's this thing going to look like from the outside? What's the API going to look like? What's it going to do? How's it going to behave? Then you do the coding, which is problem solving. I've got a failing test. It's nice. It's like coloring in. It's like paint by numbers. Like, I've got a failing test. All I have to do is think of the algorithm that's going to pass the test. So it's very much like a problem solving mode. I'm not thinking as much about external design, and I'm not thinking that much about internal design either. I'm just trying to make the test pass. And then I get this sort of luxury of a refactoring phase where I get to look at what I've done and think about how I improve it, but it works. And improving working code is always a lot easier than improving horrible broken code. So why don't people do it more? Well, I think one of the reasons is it's hard to see how to do it. In talks, you often get examples like this, numerical things. I'm guilty of doing a lot of prime number stuff. And they always seem like a bit of a toy example, a bit of a sort of contrived thing. And the questions are normally like, in the real world, what do you do? How do I handle all that user interface stuff? How do I handle all that data stuff, other services I have to talk to? So we don't have like loads of time, but what I'm going to hope to do with this talk is to show how a TDD approach can be used through your whole architecture by giving through example. Now, to borrow a bit of some concepts from behavior-driven development, I want to talk about rules. So the behavior of your system is really what are the rules of the system. So this idea of a rule is like what can be done in your software, what can't be done, what things cause other things. Those are the rules, and those are the things that pretty much are implemented in the system. They're the algorithms that drive the system. So part of what we have to do as developers is understand what the business rules are meant to be and then translate them into code. We have this idea of a feature that I'm not going to dwell on. And you can just think of a feature as like a unit of deliverability. So it's what set of rules have to be delivered together for it to have the impact that we want. So maybe if we let people write checks, we also have to, you can write a check and then that's like money, that's a rule. We might need to also implement the rule that the check is only like, you write a check for the amount of money you have in your account. So which chunk of things need to be delivered together? So a feature has many rules, but it's nice to keep them small because then you can deliver more regularly. And then a rule would have a set of examples attached to it. And this is the BDD core concept, is that you talk about the behavior of the system through examples. There's a format for it. There's a conversation format, workshop format called example mapping. I'm not going to go into the detail of how you actually run that session, but let's look at the kind of outputs. We've been talking to a business stakeholder about what the system should do. I'm going to build a feature called placing an order. We talk about two rules. Items are aggregated in the order, and the order can only be submitted if not empty. So those blue things might look familiar. It's the sort of things people write in tickets, right? It's generic. It covers lots of different cases. And then what we can do collaboratively is try and come up with some examples of what would happen in a specific situation. So items are aggregated in the order. I don't really understand what that means. If you add a burger, it says burger times 1. Okay. If I add a burger, fries, it'll say burger times 1, fries times 2. There's a typo there, but don't worry about it. That happens in workshops. So now with those examples, I get what the feature's about. So generating them is pretty simple. The order can only be submitted if it isn't empty, so an empty order won't submit. And if I add some fries to an empty order, then it will submit. Very simple. So this is a useful practice anyway to understand features, but then they're going to drive acceptance tests. You can turn them into acceptance tests. You can turn them into offline acceptance tests. So you can write this stuff down. You can call it an acceptance criteria if you want to. You can stick it in Jira or whatever. But the important thing is, you can write these after you've had the conversation. You can write out a sentence. So if our system works, then we're going to be able to add a burger and it'll be on the order. And if I add burger and 2 fries, it'll say it'll aggregate the fries. This is very simple because we've only got 45 minutes to go through the whole stack. So if you think about the end user, they're someone who wants to order a burger, right? They have 2 kind of ways of interacting with the system, 2 use cases, I guess, right? They need to have a way of adding an item to the order, and they need to be able to submit the order. And if they can do those two things, we can implement the feature. You can just sort of look at the feature and figure that out. And those will be exposed in some sort of services, and then behind it there'll be some sort of model of the system. So I'm going to show a fairly decoupled architecture because it's the most interesting to talk about different types of tests. So if you think about how a user is going to add an item to an order and submit an order, they're not going to be calling services. They're not going to be calling methods on services. It'd be great if they could. If we could directly call PHP methods, that we'd all enjoy that. But really, they're going to have to go through a load of stuff. To move their arm and click on the mouse that sends a signal to a browser, that runs some JavaScript maybe, that maybe talks XML HTTP to a web framework, and then that calls the services for them. So they're like puppeteering this big chain of things. And then there's a bunch of infrastructure underneath the domain model that is needed to do things like persistence. Persistence is a good example, but other things like job queues, other services that provide different functionality that you don't want to build into your core domain. So there's all this stuff, and if we do our acceptance testing the way a human would, like we click on stuff, in our browser, if we're testing that way, then where is the rule actually implemented? Should I remember it? The rule could be implemented in the JavaScript. The rule could be implemented in the PHP, in the domain model, or the rule could be implemented in the persistence layer. We could have a trigger or something like that. And that might not be what you want. It might be that by choosing your testing strategy, you'll be able to enforce some guarantees about where in your architecture rules are implemented. So the reason I'm showing a decoupled architecture is that I'm pretending, but it's really important to me that the rule is implemented in the core of the domain model. That might not be the case. So you might be working on a system, some rules, it might be fine for them to be implemented in the browser. But hopefully you'll be able to see how the same principles will apply in that case. So in my system, an old-fashioned PHP system where the backend's the king. If I apply acceptance tests to the core, that's going to have a big benefit that I'm going to know that the business rules that I care about are implemented in the core. It's also going to help because there's less stuff to worry about when I'm building things. If you're using a framework that has a tightly coupled data layer, you might not be able to do this, but it might not be a problem. So it might be fine. You might be fine if stuff is implemented either in the PHP or in the data layer because it's not like trusting the browser. In that case, maybe you test the whole stack with your acceptance test. We're going to say, I want to test just this bit. So start by acceptance testing at the service level. We're going to go fastish. The aim isn't for you to read and understand all of the code. It's more to get the feel of the process. So I'd start by making a service test, and I'd make the test first, obviously, but I'm just going to show you what objects they correspond to. And let's put it in a folder called application. I'm not that tied to the naming strategy. You can call it services or application services. The idea is that services are what everything else that isn't outside, they're what's exposed to the outside world to call. And I'm going to use the Symfony kernel test case because that will let me keep my services in the test container. You don't have to. You could instantiate them all in the setup, but I assume my services are going to have some dependencies. So what's the actual test going to be? Well, we had a sentence from earlier. Make a new order, add a burger, check it's on the order. So that's a really good place to start with an acceptance test, because you can almost read the test back to someone in the business and they remember it's what we were talking about. So here's an acceptance test. And so I start by writing this test. There's no service yet. It doesn't have any methods. I'm just trying to think, if there was a service like that, what would I want it to look like? So I'd like to be able to create a new order. I'd like to be able to add an item to the order. I'd like to be able to list the items in the order and get this array of stuff back. And that's the test. There's a particular style I'm using here. Firstly, I'm trying to limit the amount of objects. I'm trying to not use anything from the domain model here. I'm trying to use scalars. If it's really complicated, you could maybe define some DTOs that belong to this application service. But everything is really just scalar values, because I don't want the things calling the application to have to know about the domain model. Also, everything here is stateless. So there's an assumption that maybe the create new method might be called, and then sometime later, the add item method might be called on a different process, in a different process, different machine. Because we know that this might be implemented as a web, shared nothing architecture, PHP web app, or it might be a console command where I'm running separate commands. So each of these things is returning an ID that's then passed into subsequent calls. God, talking about that for too long. So obviously this test fails because none of this stuff exists. It doesn't even fail really. It kind of breaks dramatically. PHP breaks. So I can get it into a failing state by just making the object and giving it enough stuff that the failures are more logical failures. If the test says this is what will come back, but an empty array came back instead of syntax errors. So that's the acceptance test. What do we do next? We TDD the domain model and other stuff. So it's quite normal to have a failing acceptance test for a long time. What we're going to do is have a failing acceptance test, write a failing smaller test, calling them micro tests because people argue about what unit tests are. So micro test is any small, tiny little quick to run test. And probably if they're small enough, they're probably only comprehensible to developers. So the micro tests are probably things run by the developers. So I'd write a failing micro test and then make it pass, but then the acceptance test hasn't passed yet. I have to make some more objects, give them more responsibilities, do more stuff, until eventually at some point, the acceptance test passed because I made enough objects. So you can see there's two cycles going on. So we're doing the TDD cycle, but we're at a different stage of the cycle for each type of test. I still know where I am. I'd normally would run the acceptance tests separately. At the terminal, I'd run micro tests and acceptance tests, or you can have a make file, or you can configure your IDE to do it for you. But so you always know, well, I haven't passed the test, I haven't passed the acceptance test yet, but all my micro tests are passing. And you get to a point and you say, okay, my acceptance test is passing. So I write another acceptance test. Let's see how that feels. So I looked at my service test and think, well, what does create new have to do? I've only put a dummy in so far. It's going to create an order and it has to return an ID. So it's going to ask the order for the ID. And the order is going to be part of my domain model. So the application service is going to use the domain model. It's not going to expose it higher up. So I'll write a test, but there's not much to talk about yet. You don't even need to read that. It's got an ID. It has an ID setter and getter. So it's a worthless test, really. I often might defer writing that till later. But I won't show you the implementation of order. It's obvious. And that's not going to be enough because the ID is null. So I've made the decision early on that the ID isn't the responsibility of the order entity. Now, you can obviously use UUIDs or something like this, but we're in that sort of scenario where it's the database's job, mostly to make it more interesting. So I have to introduce to the service the idea it depends on some sort of repository, an order repository. Because I'm showing lots of objects out of context. I'm erring on the side of having loads of suffixes on everything. I know there are some naming arguments, but the order repository interface, the service is going to be constructed with a repository, and then after creating the order, it's going to add the order to the repository. And as a result of that, the order is going to have an ID. So our acceptance test is still failing because this thing doesn't exist. So we need to generate a repository. So we're going to TDD the repository. It's not going to be the doctrine repository because I don't want to start thinking about databases. But we'll make a version of the repository and we'll call that a fake. Now, fake is really useful in a situation where you have a fake versus a mock. So instead of using a test framework that's mocking functionality, a fake is really useful if you want to have a version of a dependency that behaves the same way as the real dependency without you having to spell it out using mocks every time. And that's normally the case where it's a kind of driven dependency or a downstream dependency. It's a piece of infrastructure that only exists because your domain model needs it. Right? It's not calling the domain model. It's not a peer. It wouldn't exist if the domain model didn't exist. Like this repository. So we're going to TDD it. I'll probably keep it here. So I'll make an infrastructure fake folder and have a mirrored folder on the test, but then we'll have the interface that it implements being part of the domain model. There's a little imbalance there, isn't there, that hopefully we'll fix later. So I'll write some tests for the repository. I know one thing it needs to do already. I know that I have to have this method as part of its interface. And what test would I write? I could write a test that just adds an order and nothing happens. But that feels a bit weak. And in fact, PHP Unit will mark that as a risky test. But thinking about it, there is some behavior I know. It gives an ID to an order. So that's what the test here is saying. If I call add on a repository with an order, then the order will now have an ID, which is pretty trivial, but it makes me make the repository. I have to write an add method that returns doesn't return an ID. It sets the ID on the order. And I do it a nonsense way. I'm just going to keep them in an array in memory. And, I'm counting the size of the array, so it'll increase. That's good enough for now. And that's it. And that's really it. So we're going to do the same thing, working through the rest of the acceptance tests. So far I've got a failing acceptance test. I've got a unit test for an order entity, and I've made a start on the order entity. And I've got one unit test for my order repository, and I've made a start on the order repository. So let's keep going. The next thing the service does after it creates news, it calls add item on the service. So add item is going to get an order from the repository, add the item to the order, and then update the order. So I need to add a get method to the repository, an update method to the repository, and an add method to the order, but maybe it doesn't have to do anything just yet, because there's not really, I can't think of a test that I could write about add yet. So, but there's loads of stuff I can add to the order repository. It finds an order that was saved. So if I save an order, if I call add, and then I call get with the same ID, then I should get a similar object back. So if I save it and then pull it back out again, I should get the same thing back. If I get an order that doesn't exist, so generally everything should kind of be driven by the acceptance test, but you'll think of edge cases that aren't in the acceptance test, and you should write micro tests for them. If it's something super business critical, you should go and have a conversation about what the behavior should be. But a lot of the time, we're just trying to. A lot of the unhappy cases, the things people should never do, aren't things that are going to come up in conversations or be in your requirements document. So it throws an exception when getting an order that doesn't exist, and it modifies an order that's updated. So if I put an order in a database, and then I modify it, and then I save it again, and I get it back from the database, then the update worked. We didn't get a key collision, anything like that. So I won't show you the implementation of this in the fake, but this is all just array stuff that we're doing in the fake. The code is all on GitHub, and there's a link at the end. So after this exercise, we've got a nice interface for our repository. We've kind of derived from how the service is using it. So when we implement the actual repository later, we know it has to have these methods, and it'll slot right in. But there's more to it, isn't there? There's behavior. This is what I mean about it being a driven dependency. There's behavior that we feel like every implementation of this should have. And that's captured by the tests. Every implementation should give the order an ID when it saves it. Every implementation should throw an exception if you ask for something that doesn't exist. Every implementation should be able to update stuff. Which is different, right? Some other interfaces, you might not have any requirements. Like if you think about something that recommends, we're talking about food ordering, something that recommends dishes to people, you might not have any requirements. All you know is it just returns an array of orders because it's off somewhere else. It's some magic, machine learning thing, which is much more like traditional stubbing. You'd say, if the recommendation engine returns these things, this is what we should do. So you're more thinking like, what could it throw at us? Whereas here, these tests are about, here's some behavior that it has to have. Then the last bit, the order has to be able to list items. The service has to be able to list the items in the order. And then inside the service, we do that by loading an order and asking the order for stuff. And the service's job is to map whatever format the order entity returns these things to what the service contract is. So here we're just manipulating an array. And so this will still fail. I need to make the order have that functionality. So if I add fries to an order, it should return an array saying it's got one set of fries. And then the acceptance test passes. Hooray. So we've driven out a handful of domain object tests, a handful of repository tests, which I know at the moment might feel a bit of a waste of time, but they'll come good at the end. And we've passed an acceptance test. So we know the core of our system implements a rule. It's a good time to commit. Look at the clock. If it's time to go home, go home. If it's half an hour till you go home, go make a coffee and go home. Otherwise, let's do the second acceptance test. So the second one was, if we add a burger and fries and another fries, it should say 2 fries. So when I write the acceptance test, the interesting thing is that there aren't any new methods on the service. So when you're introducing a new concept, you have to add a lot more stuff. When you're adding just like another variation on what should happen, I haven't had to add any new methods to the service. These all exist already and they auto-completed and all that. But this will fail. What will probably happen is it'll say cheeseburger 1, fries 1, fries 1. So we need to look at now into the system, which the service doesn't work. The acceptance test tells us the service doesn't implement the rule correctly, but we know which object's responsible for that. It's the order object. So we can add an extra test to the order object, modify the order object's code, and then both of our acceptance tests are passing. We've got this stuff that we've built. So we've got 2 sets of tests. We've developed 2 acceptance tests that apply to services and they execute relatively slowly. They're still PHP only. They're still just running in CPU and not hitting disk particularly. The only thing they're doing is they're booting the Symfony kernel each time. That's the main reason for the slowness. And then we have these micro tests, which are some like traditional unit tests for the domain model and some unit test like things for the fake infrastructure. This is pretty fast. This is the sort of thing where you would run it every time you hit save, almost. And you'd never sort of think, oh, I can't be bothered running the tests. You can set up things to automatically run it every change, that kind of thing. So maybe that's the whole feature. Let's imagine that's the whole feature, those 2 acceptance tests. There were 4 originally in the example map, but let's move on. So I know now that the rule is implemented inside the core of my system. Now I could, in some cases, make a pull request and deploy that if it's something that isn't modifying existing behavior. But probably I'll want to hook it up to the real database and hook it up to the real user interface. And which one are we going to do first? Well, we do the user interface first. It won't work because we're not really persisting the data. So let's look at the infrastructure layer. So the thing we're going to do is going to reuse our contract tests to TDD the real infrastructure. So we've got this structure at the moment with fake order repository, and that contains a lot of useful tests. We're going to create we've got a nice interface in our core domain, so it's obvious that we can create a doctrine implementation of that interface and write tests for that as well. Write the test first, of course. So if I look at the faked order repository, which bits of it are specific to being fake? Well, it's really just the setup. The setup's instantiating the real order repository. Everything else, you'll notice the property is typed. It's typed as the interface. That's deliberate. It means that all of the tests are only interacting with it through the contract, through the interface method, through the interface methods. So my PHP doesn't really enforce that well, but my IDE will tell me off if I call any methods that aren't part of the interface. Or static analysis tools will if you run them on your tests. So I can take all those tests and put them in a trait. And then a trait won't really have any evidence about which implementation it's designed for. Everything is just referring to the interface. So maybe I put that trait symmetrically with the interface in my file structure, just because that will make me happy. So what we've got is the idea that we've got reusable tests that we're going to apply to our doctrine implementation, but also could apply to any future implementations. If we make a web service storage version of the order repository, if we start storing our orders in like a third-party fulfillment system, we can use it, as well as reusing the interface, we can apply these tests to the new implementation. So let's look at the doctrine order repository test, because that's the first thing we'd write, of course. So it uses the trait, and then I have to think, how am I going to get my doctrine repository? Well, I'm going to use the kernel test case again. You can try and do it without, but I think I've seen Jakob do it without it. But really, if it's going to depend on the doctrine entity manager, which you want to be configured properly and have all of its connection stuff set up. So the setup is really just getting my order repository and also getting the entity manager, just so that we can close it in a teardown. This is where I'd say any questions if people are live. I can't see any in the chat. But the only tests we've got in there are the ones from the trait. Now, if I think of more things I want to test about the doctrine implementation, I should think about whether they're doctrine specific. So, if I think of some test that I want to test some edge case about the unit of work, I'd put it in this class. If I think the fake should do it as well, I would put it in the trait and then make the fake do it as well. Then the order repository, you don't really need to see. It's pretty easy to, given those 3 methods, it's pretty easy to implement them in Doctrine. Oh, I just seen a question. Barney says, why is the entity manager nullable? Because I set it to null in the teardown to free up the memory. Sorry if that was ages after you asked, Barney, but it's a good question. So implementing the Doctrine version of the order repository isn't what it talks about, so don't worry about it. But I just have to say, well, how do I add an order to the database using Doctrine? How do I get an order from the database using Doctrine? How do I make sure if it isn't found by Doctrine, the right exception is thrown, etc.? That isn't the hard bit. The hard bit is, it's actually really easy. I've just made a test using this trait. I've got 4 failing tests. I've written an implementation. The things that actually take up the time are getting Doctrine sorted out, configuring the database connection, writing mappings, figuring out how I'm going to have a test database and fixtures. But none of that's testing. That's solving. None of those are test challenges, really. The way I normally manage the database is to have that outside of the test tool. Delete the test before every execution, that kind of delete the database before every execution. But the point is, I'm not thinking about, I'm not writing any tests during this phase. I'm separating out the thought process in the same way that the TDD cycle I mentioned at the start separates out the 3 things you're worrying about when building software somewhat. This kind of approach, I've done all my TDDing, done all my test-driven development of the fake order repository, got all that design out of my system. Now, implementing it for Doctrine, I'm really just filling in the blanks in the design and trying to remember how the hell Doctrine works. If you're on the Symfony developer Slack, you'd have seen me asking some questions to write this code. So now we've got 2 acceptance tests that take some time. We've got 9 micro tests that take a lot less time, but now we've got this Doctrine stuff that takes much longer. I mean, it's taking much longer than the acceptance tests. That's with SQLite. It would be more like seconds, whole seconds, if you can imagine tests taking that long. If I was, connecting it to MySQL. So this is a difference between the acceptance tests and sorry, I'm reading a comment, that's really bad. So you've got the acceptance test and the micro test that run super fast and have no dependencies. And you have the Doctrine infrastructure tests that run, they're okay in SQLite, but you have to worry about having a database. So I have to install MySQL or Postgres probably, or get a container running, all that stuff. So there starts to be a divide. Probably the acceptance and micro tests I'm running all the time. Probably the Doctrine stuff I'm remembering to run before I do a pull request, or maybe just letting the CI server do it. Unless I'm working on that repository, they're not going to fail. So by having the same tests aligning the fakes and the Doctrine stuff, it lets me not run the Doctrine stuff very often. So I'm running it with the fake infrastructure, and then every so often a test somewhere reminds me that the Doctrine stuff is working the same as the fake stuff. A nice place to run the acceptance and micro test, the fast test with no dependencies, is in your Docker build. That's something I started doing recently, and it's nice to not be able to build the container if there's a failure. Of course, that can't depend on any external infrastructure. So that's the infrastructure. Let's look at the UI. How do we build the UI that's going to connect the person to the services? Well, we're going to need to write a user interface test. You could rename your controller folder user interface if you wanted to have everything line up. I do like everything lining up, but I thought it might be too much for this talk, and it's not a folder structure talk. So we're going to need the kernel, we're going to need a controller. The point is we're going to use our acceptance tests to write our UI test. So the two sets of things we built in the first case that weren't unit tests, acceptance tests and contract tests, we're reusing them both now. Kind of. And I don't think we need to run both acceptance tests. Testing is all about confidence, and I now know that the use case exists on the service, and how many UI tests do I need to write? How many UI tests do I need to write that hit that service and then put the result of that service on the screen? If it's always just calling the method and it's always displaying that array on the screen, I only need to run one UI test that checks that. If there were different services I was calling, if there's different variations on what data can come back, like it might be an array or null or an error, I'd want to write tests that cover all those eventualities, but I'm looking for a subset. So let's take one of the acceptance tests from the start, and I'm going to write a web test case. You could write a Panther test case as well. The same approach would apply. It would just be slightly slower. Well, sorry, much slower, but it would be a real browser. So you might need to do that if you've got JS and stuff going on. And to start with, I can just copy in the acceptance test I had, because it's going to be the same. We want a test that maps to the same sentence, and I think it's quite nice to just replace bit by bit, call it the same thing. So how do I create a new order in a web context? I create the web client and I go to the order page. How do I add order items to the order? So what I'm doing as I'm writing these is I'm designing the UI and the routes. So I've just made a decision about URLs. Now I'm making a decision about user interface. Is it a link? Let's make it a button. So I have to find the form and submit the form and say, I'd like a cheeseburger. Because that's repetitive, I'll hide that somewhere in a private method or on the test. If you're doing loads of this stuff, you might end up with lots of private methods on tests, and then you might decide to make them into public methods on helper objects. I have seen actually, as like Heliso was talking about, let me just go back. He did a talk where he talked about making web implementation of the same service. So you'd have an orders service with a create new method, and then hidden inside that would be the web automation. I've not tried it yet. So we add all the items. We add all the items to the order, same as we did in the acceptance test, except we're going through the web. And we check the stuff is there. We do that by checking this stuff on the page. So that's just the Symfony web test case language. Like I said, if you're using Panther test case, it'll run a real browser, but it's the same API, or a superset of the API. So I'm reusing that thinking I did earlier, and now I have to implement the web interface because I've got one failing acceptance test, right? And this will be running with the real database. So the first bit is it goes to this orders page. So I need to make an orders page. The second, so once I do that, it'll stop complaining about the missing route. And then it'll start complaining, you've told me to click on buttons and there aren't any. So now I'm going to cheat. We're working on this adding to your order feature. So I'm going to assume that we've already built the menu. So I could just hard code it into my page. It would be getting it from a database somewhere. We built it last sprint, And it looks amazing, as you can tell. Maybe I should use Tailwind. So what's going to happen now? The test's still going to be failing, but the message will have changed. It'll say, I click the button and it's submitted to somewhere that doesn't exist. So I have to write the page that the button submits to. And that's going to add an item to my order, right? And redirect back to the main page. So all in the same way as when I was doing the doctrine implementation, I was thinking about databases the whole time and not really thinking about tests or domain logic. Here, I want to mostly be thinking about web concerns. So how do I know which item to add to the data, add to the order? Let's make it so that it was submitted in the form. How do I know the ID of the order? Like tracking the ID of the order from request to request is a sort of web concern. Let's say it's kept in the session. And then I do something in the middle and I send you back to the order. Now that's something in the middle. If only, this is where the magic happens, right? If only there was a simple way of creating an order if it didn't exist and adding an item to it. But wait, there is. There's a thing called orders service. And it has a method. If there wasn't an order in the session, I can call create new and save it in the session. And there's a method that adds an item by ID, just by strings, adds an item to a specific order. That's not a coincidence. It's an artifact of the way we've built it. But it's very satisfying because I haven't had to solve any problems that aren't web problems. Like the Lego kit of stuff I need to build my UI, the domain logic's done. And it's like in a really convenient format. It's in a really convenient format because I started by writing a test, a service layer test. And the first thing I did, if you remember the first slide with code on, was making decisions about this API. And being honest, obviously when you're writing code like this for a talk, you go back and refactor stuff. That's the one bit I didn't change. The domain model changed a few times because I made it more and less complicated. But the decisions I made about what the service should look like pretty much stayed consistent. So now we've got an endpoint that adds an item to the order. The last bit is the order needs to be listed on the page. So when I get back to my boring static page, what do I need to add? I need to, if there's an order in the session, call list items. It's already got an array structure that's different to the internal array structure. The service has an array structure it returns. Items there is, ignore that. That's an artifact of a previous version. So we get the order ID from the session and we say list all the items in that order and pass it to Twig. It's pretty much a one-liner. All of the actions become one-liners in your service. So naturally, they're available as stateless one-liners in your controllers. So the things I'm doing to make it pass, I'm not doing any domain logic. I'm thinking about routing. I'm thinking about sessions. I'm thinking about forms. I'm writing. Oh God. I'm writing Twig templates and ignore the third and fourth bullet points. And I'm sure you're wondering if it works. Of course it does. It's beautiful. Watch out, Just Eat. Okay. So that's feature complete. Obviously arguably there's some front end improvements. But we know that the things we talked to the business about were implemented in the core, and we know we've got a high confidence level that the system as a whole supports them. I'm happy committing and sending it to a manual tester to find all the gaps and things we didn't talk about. So the top two rows, I've got these super fast PHP tests that I can run the whole time. The bottom two, I've got slightly slower tests that I probably only run when the infrastructure is available. They both run through Doctrine. They both involve a database. The end-to-end tests, if you had used Panther, would be much slower, and they'd also involve, web connections, that kind of thing. So that's kind of it. Let's recap. So for this specific kind of architecture, and remember other architectures are available, I start with acceptance tests at the service level to make sure the rules are implemented in the core. I TDD'd the fake infrastructure, and maybe when you were watching it felt a bit over the top, but then when we built the doctrine one, it was really handy to have had all those tests worked out in advance. That was point 3. And then when building the UI tests, use the same acceptance test outlines as we did for the services, and magically all of this stuff exists in your service layer, ready to be called from whatever UI you're using. The general points are: start with acceptance tests, start by talking to someone, and try and make those conversations things that are easily processed into acceptance tests. Test at different levels in the stack. Testing the full stack isn't better because it's testing everything. It means that there's less control over, think about how your tests enforce your architectural decisions. It means there's less control over how the tests are influencing the architecture. And that is it from me. If you want to see the code, that's the URL. Feel free to rip it to shreds. I wrote most of it yesterday. The talk's been on the back burner for a while. And that's it. I'm happy to answer any questions if there are some. Didn't see many in the comments.
No, thank you, Kieran. Oh, let me just mute that one. Thank you so much. That was again another fantastic talk. I think so. So that's really interesting. I mean, certainly the bullet pointed list you had at the end, or the ordered list you had at the end of the steps through it, starting with the service tests, breaking that down with unit tests or micro tests, as you call them. I like to call them logic tests, just to kind of really label what they are. And I think that's a really kind of valid and beneficial way of approaching tests, because you start at some kind of level halfway in, and then you break out the smaller parts, and then the integration and end-to-end part always feels a little bit more black boxy to me. It's more difficult to kind of get started with. So I usually leave that till last as well. I like what you were saying about sort of mocking versus fakes and stuff. Now, I was chatting to a friend, Ed, about mocking recently.
Yep.
And we were talking about the difference between mocks and fakes and stubs and spies, and sort of using doubles versus mocking. And he gave me the point that if you're mocking something using a test framework's mocking methods, you never actually really get to see the full interface of what you're mocking. You can mock just part of an interface, and it never makes you think about the exact interface that you're actually implementing or designing, whereas using a fake would make you actually have to implement every single method on that interface, which makes you actually think about the architecture. And if you find that your doubles are really hard to implement, then that's a smell of a poor architecture there as well. So it's interesting, I think that you said about how your approach drives the architecture. It helps you think about the architecture. But I think that's a thing as well, is that there's multiple layers of this that can help you drive the architecture of your application.
Yeah, and the kind of infrastructure we're talking about.
So Barney had one or two questions in the chat as well. I think that's all related to the entity manager being nullable. So yes, I'm not sure if we did. Jakob, did we have anything come through on the other chat channels?
We have one question on Meetup, but it's to Jim. Do you think there are situations where semantic class names are a good option?
Yes. When doing complicated things like navigations and stuff, I think it's a really good idea to do that. If you do Tailwind with really complicated stuff, you end up with a lot of things, and even more stateful things, that it becomes unreadable.
Great. Was there anything else? And Kieran, I'm so sorry. I just realised I had my headphones on mute, so you may have been talking back to me when I was talking about the infrastructure there. I may have just completely spoken over you. Did I do that?
Yeah, but it's okay. The thing I would say is that there's different approaches for different types of infrastructure. So the approach today was very much about infrastructure where we're really interested in the behavior of that infrastructure. So writing tests for it, starting with a fake makes it easier to write tests for it. Make sure it's got the behavior you want. So it's like the system we're building feels like it has to dictate what that behavior is. There's other and a fake is a good option for that. You can use mocking libraries instead of a fake, but often you'll end up with like really verbose mocking. Whereas in fact, you could have just plugged in like especially a repository. It's like your save method is going to get called, and then later when someone asks you to load the thing, you should give back this object. That's loads of stuff in a mocking library, but you can just make an object that just does it. There's other situations though. If I've got something like a logging dependency that is just a command I send out, like I have to just report something, a mock is a great way to test that because you're just testing some method on another service got called. Similarly, if it's something I'm just going to get a load of data from and I don't know what the data is going to be, a stubbing approach makes a lot more sense. So they're more sort of like peered services or other microservices in your system, whereas this is like infrastructure.
Great, yes. Okay, so I don't know if we have any other questions in here. No, I mean, we've got a couple of comments. Yeah, thank you, Kieran, from Lee, who always enjoys your talks. And Chris says, thank you to the hosts. You're very welcome. And to the speakers, it's been really good stuff. Yeah, again, I just want to, before we wrap up, I just want to say thank you to all of the speakers that we've had tonight, both Kieran and Jim, and to Jakob for manning the fort with the social streams. And thank you to everybody who came along to the meetup. We're already planning the next one. So that will be in 2 months' time. What are we now? February, so that'll be April. And then as Kieran was saying to me earlier, so hopefully by June we'll be in person again. But we'll try and figure out what we can do with the streams, because I think, you know, we are definitely reaching people from a much wider audience, and it's been lovely having everybody come and join us throughout the pandemic. And I think it's definitely something that we've been able to do to enhance our community. Thank you so much for sticking with us. We've had 1 or 2 teething problems, I think, with trying out the YouTube streams, with the chat, and with I've had some audio problems tonight, which has culminated in me talking over Kieran, which I'm fairly embarrassed about. But yeah, we'll figure it out next time. And I'm going to ban Jo Carter from the raffle next time around as well. She just seems to have a knack at winning this bloody thing every single time. Oh, and as promised, I have put the raffle site up on GitHub, so I'm going to post that in here. So that's on github.com/Symfony UK raffle. Feel free to have a look at it and clone it. I don't think I've committed my AWS keys in, so feel free just to have a look and poke, and PRs are welcome. Thank you everybody who came along tonight, and we'll hopefully see you all soon. Right, gentlemen, if you are still there, thank you so much for being with us tonight. No, everyone.